Fantastic. All right. So now you can see what all of those things stand for if you didn't already know. Sorry for all the alphabet soup. One of the goals here is to try and demystify this, because one of the problems getting into it is how many different things. Oh, sorry, so for people taking pictures, that's great, and you're welcome to. I am going to be posting these slides. So I'll put a link on the meetup group and on the YouTube and on both meetup groups. So yeah, ask questions at any time. There's a lot of slides to get through, so I'm going to go at a fairly rapid pace. But I also don't want to leave people behind if things aren't clicking. And if people do have comments where I've gone off the rails, feel free to interrupt me. I just want to talk a little bit about CRUD. And for anyone who does databases, familiar with this concept, create, report, update, delete. And this is how developers tend to think about how the data interacts with their application. And the problem with CRUD is every time you do an update or a delete, you're really destroying data. You're taking what was there for an update, you're throwing it away. You'll never have that again. Maybe it'll sit on a backup tape somewhere, but odds are that data's not coming back. Same idea for deletes. So what was that data worth? We don't know. And one of the reasons I've finally been getting them to warm up to the idea of CQRS where I work is that they keep coming to me with things where they say, hey, can we get this out of our database? And I'm, oh, well, we could if we designed it for that, but we didn't design it for that. And so we can get that moving forward, but we can't get that for what's already happened. And this is why. So this is the basic idea of CQRS. We're going to treat the idea of putting data into permanent storage as one problem and getting it out as a completely separate problem. So it's two separate problems, putting data into the database, pulling data out, and we can optimize both so that both we can reduce a lot of problems. Now, one nice thing about CQRS is there's a lot of different right ways to do it. And it was popularized starting probably about 2012. The Microsoft people at Azure saw CQRS as a good way to get people onto Azure. And they really thought of it as a distributed computing idea. And it's really good at that. But it really put all the CQRS people into that mentality of distributed computing. And it really doesn't have to be. So we got all this extra stuff bundled in with what everybody's been doing, built for distributed, whether you need it or not. And so one of the things I try and do is to take a different right way that's not based on a distributed environment. It doesn't mean you can't put things in get some distributed, but it's not built with that in mind. Another thing just to keep in mind as we go through this is that you can always think about Git or any revision control system or accounting, and it'll kind of put you in the frame of mind for event sourcing. And we're going to move into the difference between CQRS and event sourcing. So there's the alphabet soup, and this is part of why it's so difficult. So when I learned about this, first it was CQRS, and then I had to learn what event sourcing was and why we use that with CQRS. And then these guys are all from the world of DDD. So they're all using this terminology and this jargon from DDD, but they don't tell you that's a prerequisite. So you're just kind of Googling these terms and finding out, oh, this stuff all comes from DDD. So this is, and I'm going to have a lot of these really light definitions here. Obviously, DDD is a heck of a lot more than this. But basically, we've got ways of helping developers and business people to communicate and to make sure we're on the same page. And we've got strategies and tactics that developers can use. And a lot of these you're probably already familiar with. So BDD, Cucumber was mentioned in the first talk. And Cucumber is a tool for doing BDD, as is Mocha. And we talked about the software test, which was written as a gherkin. And we're going to see a gherkin. We're going to use that to test our own implementation. CI, the topic of the first talk, and some other terms here that you may or may not be familiar with. But a lot of this stuff, it's coming from the same place. CQRS came out of DDD. If you're doing DDD, one of the things that you're going to do is event storming. And that's something where you talk to your stakeholders about all the different things that happen that change the state. of your application's data, all of the things that you need to process, and it's one of those tools to help understand business requirements. Those become the whens in your gherkins, which we're going to see in a little while. And from those, the idea of just storing the events is how CQRS emerged. So your write models, the ways that you represent the information going into your database, it's all based on the events that change the information. The read models just evolved naturally from all the different ways we need to use the data. So we've got a lot of different uses, different ways we need to process the data, and we can tune all of our read models for that. So out of CQRS, event sourcing was just a natural thing to emerge. We had this idea of domain events. We had the idea of a separate write model. Event sourcing, the idea of it grew out of that. And the basic premise behind event sourcing is that if we store every event from the creation of an object, of something in our application, and we store every event through its history, if we replay that event stream, we're going to end up with our present state. And those things that we're storing in the database, once we write them, we never change them again. They're immutable. So those items are truth, Scout's honor, right? So that stuff is there and you can depend on it. So if you've got a bad query or something that might have destroyed data, it's not going to happen here because this data is never changing. I'm going to do a couple of phases here where we look at working definitions of a few words just so that we can cut through the jargon. A command of the CQRS, it's the C in CQRS, is our intent. So this says, I want to do this with the application. I want to have this effect. The event is what happens because of my intent. So I intend to register on your website. The events that come out of that might be user registered, user provided email address, user set password. So these are all things past tense. These happened. Once we've logged that event, it's happened, and we've got facts, which is nice. Aggregate. So an aggregate is something you're going to see a lot. We're used to dealing with models and entities when we work with things like doctrine or eloquent. Yeah, sorry, not so much a Laravel guy, but the same idea, right? We're used to working with those models. An aggregate is something that's built up from other things, and in this case, built up from events. An aggregate root is an aggregate which has a unique identifier, typically a UUID. We're all feeling good about all this so far? Everything's making sense? No questions? Okay. So we start with commands, our intent, and the purpose of the code behind a command is to determine what events come out of that command. So it might look something like this. In this case, it's just a simple function. A lot of CQRS libraries will have classes for each command, and that's fine, but it doesn't need to be that complicated. Command, we're validating that the request within the command it's okay, it's legal, and we're going to return, once we've determined what events are the outcome of the command, we're going to return those as a list. Now this is the simplest command, or the simplest concept of a command. A lot of more complicated, and especially the ones based on distributed computing, they're going to have an event bus that the commands are going to be pushing events onto, and they're going to be receiving commands through a bus. You can't even always throw an exception. There's some architectures that don't allow commands to say no. So a few things for us to consider. Where should we place them? For me, I like to have them grouped with the aggregate root. I like to keep everything about an aggregate in one place. You could have a separate area in your application for commands. Again, more than one right way. Can commands say no? Well, it depends on your architecture. So if commands can say no, then you want your commands to be able to say no. And a lot of people, especially from earlier on, really thought that was a no-no. but the current thinking is moving more towards the idea that events should be allowed to say no if there's any problem with the business logic. And there we've got into the whole idea of the distributed and how that impacts things. So our events get built up into aggregates. And that happens through apply functions. So in this case, I've got a function that I'm running inside the model for the aggregate. And it takes an ID, the unique identifier for the aggregate root, and a payload for the event. And in this case, I'm just going to set a field in my aggregate based on what happened in this event. So again, the simplest possible implementation of an apply function. In this case, I'm using an annotation, and that's something PHP developers tend to either really love or really hate. I like to use them. I find them very useful. And in my own library for CQRS, I have the ability to register a class and have it look for all the apply functions and have them automatically trigger based on the event. The event is a constant in the class. It's a string. I like to have my events actually have names that are meaningful so I can look at an event stream and see what the intention of those was. The problem is sometimes your language will change throughout a process, or sorry, throughout a project, and those names become lies. And so that's the sort of flip side to that problem or that convention of naming them. I'd prefer to have some meaning even if it's going to change, because the alternative is to have meaningless numbers in there and then you've really got no clue. So it's like, do I want gobbledygook or do I want something that might eventually become a lie? Either one, it's a trade-off. So you could make these constants anything, and then you'd be able to refactor your code to change that to match the language that your group uses. So we talked about annotations. Where we place these, I place them right in the model because they're acting on the data within the model. And why pass both an ID and a payload? The IDs in a CQRS application come from the client of the API for the aggregate. So if I want to create a user, the first thing I'm going to do is generate a UUID or some identifier for the user. Because otherwise, I'm not going to know what ID to use to pull that information back. Because the command can return failure, but it can't return the ID. I suppose you could try and invent something that would do that, but that's a little far out of the way the pattern is normally used. Projections are where we get into the read model. So we've got events feeding in. We know events produce aggregates and aggregate roots. Events can also create projections, which are customized tables or other types of views for your data. So again, I'm using an annotation. I've got something that happens when an event happens, takes the event, or sorry, the ID and the event. I have the whole event so that I can get at things like the date and time the event was created, its version number, and some other metadata about the event that can be useful. And within the function, we update whatever our read models are. These, I like to place them either in individual classes, or if they're really small, I might have a group of them for a model, but outside of the actual domain object. But you could place them anywhere. Should projections live in the same database? Yes, sir. Sure, yeah. So let's say, for example, that you wanted to have a grid. I've been using users, and that's going to be the concrete example later is user registration. Let's say you wanted to have a list of users in your admin panel. You don't want to say, play back every event for every user that has ever used my system so that I can generate a grid. Can you imagine how slow that would be, right? So instead, every time something happens to a user, you have things that are hooking into events to do with users that will change what's going to be in that grid. So the grid may only show name, email address, maybe role, I don't know, right? It's not going to show a ton of information. So when those things change, you're going to update your user list projection. Another thing that's going to read messages is a process manager. And the job of a process manager is to say, when this thing happens in our domain, these other things need to be initiated. And the example we're going to look at specifically is going to be when a user asks to have an email address associated with their account. We're going to have a process manager initiate a command to send an email confirmation back to the user. So that's one example, but you could have anything where a domain event has to trigger other actions to happen. So it looks exactly the same. Oh, wait a minute now, that's projector. That was projector. That's an error in this slide, I'm sorry. No, yeah, oh well. Sorry, that should have had a process manager annotation on there. Anyway, the purpose of this is still to invoke other commands. So where should we place them? Again, similar to projections, they're going to be somewhere associated with either you're going to group all your process managers together, you're going to group them by aggregate, which is what I prefer to do, or whatever makes sense to the way you're building that. Now, why not have a process manager just create the events directly? Seems more efficient. Well, the reason is that your commands are enforcing your business rules. So you don't want to have business rules, that logic rewritten in different places, applied inconsistently. And the other thing, which isn't on here and I thought is why do we need two different ways to hook events, one for projections and one for process managers? And the reason is that if you need to replay your event stream to recreate your projections, you don't want to trigger those commands again because that stuff has already happened. So anything that's in a process manager is never going to be replayed. It's only happening sort of live when the thing happens the first time. You don't want to be sending emails out to people because you've replayed your event stream to do something. So another list of definitions, and we've already talked a little bit about some of these things, the event stream. So we all know what this is, an ordered list of events for an aggregate route. Invariant. So the reason I'm putting these in here, I'm trying to avoid the lingo as much as I can, but if you're going to get involved in CQRS and ES, you're going to come across these things all the time. And an invariant is just a way to say business rule. The ubiquitous language. So I talked about the naming of events and whether those names become lies later. And you want to avoid putting lies into your code anytime you can. So you can refactor code to reflect the language that the project team is using. So this is like a dictionary that your project team is using specifically for the problem at hand. And so it may not be quite the same as a dictionary definition. For example, a book. Is a book an accounting book? Is it a book from a library? Is it the title and ISBN of a book, or is it a copy of a book? There's a lot of different definitions, and you need to nail down what you mean when you use a word. And you do that with the ubiquitous language in DDD. And you should be refactoring your code when the ubiquitous language changes. A bounded context in DDD is a difficult area to really understand and something to deal with properly. But the idea is to put a circle around the problem domain you're working with and saying things like the ubiquitous language are all limited to the problem we're defining within this bubble. And an aggregate would be defined within one of these because it's using that language. So if you might have one project with different bounded contexts within it, and in that case, each one could have different terminology for the same kind of thing. And that's where you get into DTOs, which were mentioned earlier, data transfer objects, where you use those to map between different bounded contexts. And I'm not saying this, I don't want to make this more confusing. I'm trying to give you these terms so that you've got some idea what they mean when you come across them again. Because you're going to run into this stuff all the time if you read other information about CQRS and ES. Snapshots are a way to make the event stream processing faster. So instead of replaying the entire event stream every time you need to rebuild an aggregate, you can make a projection, and it could be a projection that runs nightly or on some other schedule that takes the fully constructed aggregate at a specific version and stores it as a snapshot. So now I can bring back the snapshot and just play the event stream from that version on. When an aggregate root gets loaded and passed into a command, it needs to get recorded into the event stream, and we do have concurrency problems. And you have the same problems in CRUD, but in most CRUD applications, when you have a concurrency problem, and let me explain what that means. Let's say you've got two different users load the same form at the same time. This guy hits save, saves their information to the database. This one hits save, this guy just lost. Whatever this guy hit save on, that's the update. Anything that was saved before that is just gone, and nobody knows why. In CQRS, the aggregate root, it goes through, the record operation goes through this cycle, and it can run more than once if it needs to make sure that what gets recorded to the event stream is consistent and that it is enforcing your business rules properly. So we're just going to go through each step. We start loading the aggregate root, and it'll have a version associated with it. We pass that to a command, which looks at it and figures out with parameters what needs to happen to the aggregate root or what events it wants to create. The events get made into a list and passed into something that's going to be recorded. And at this point, they get written to the event stream in a single transaction. So this piece here, when it records, it's going to lock the event stream from other writes. It's going to say, what's the most recent version? If the most recent version is the same one we loaded at the beginning here into our command, good to go. If it's changed, somebody else has gone ahead and done something before we hit save or whatever happened, and we need to start over. So we're going to rerun the command. It's going to recheck the business logic, make sure everything is still okay. If it is, our command can go through successfully. So when you're thinking in terms of a CRUD application, you normally have a form and you're submitting everything at once. CQRS applications tend to be more event-based. So you're going to have just a little feature that says, change email address. You're going to hit it. You're going to say, this is my new email address. You're going to have another one, change of home address. You're going to do that. If me and my wife are on the site at the same time and I'm updating my email address and she's updating our home address and we both hit submit at the same time, one of these loops is going to fail, but the next one is going to load it up. It's going to say, oh, home address changed. That's okay. Let it go. And both updates are going to go in successfully without one person nuking the work of the other person. So the impact of doing this kind of thing, you get a more reliable system. The immutability of event streams mean that if you do have a bug, we were talking earlier about how, rolling back 4 days because of a bug that wasn't detected. I've had systems where we've recorded bad information for a while before we detected that we were recording bad information. That can happen in CQRS because you can record events inaccurately. But at that point, the truth is that this is the event that was recorded. And if you can put a mitigation into your projectors that say, okay, there was a problem here, the recorded information wasn't quite what we wanted, and then rerun your projections, you can recover from that as best you can. There's not much more you can do if you're not recording the right information. But you're better off than, for example, an update statement missing its where clause. Oops, just changed the whole database to read the same value, right? I mean, that's a huge, an exaggerated example, but the fact that you've got immutability there makes a big difference. And also, when we look at the concrete examples, you're going to see a lot of these code snippets, and it's partly because this is simple, but it really, even in complex situations, you should be able to keep each function really short, just doing a very specific thing. And that makes it a lot easier to think about and less likely to, easier to test, less likely to introduce bugs. More flexible thanks to separating out the concerns. And what I mean by concerns is things like not just read model and write model, but different types of read models, and having any number of projections really tuned to that specific need. Again, short, simple functions or small, simple classes. A couple examples. I think I gave that one earlier. Oh yeah, the idea of a report being slow because you've got a whole lot of joins and you want to denormalize it. There's no such thing as normalization in CQRS. There's no relational thing to any of this. You're building projections that are already pre-denormalized into whatever it is that you need there. And your events, there's no need to denormalize those either, because they're just payloads and IDs on an event stream. It can scale really nicely. So I can have different projections going to different databases. So I can actually have physical hardware or virtual machines, whatever, but I can have databases optimized for a specific read model. So I can really scale up there. I could even create more than one or have replication on a read model without impacting any other database. So if I've got something that's really getting hit hard, I can have that replicated out without any impact to the rest of the system. And this is really cool, this one here. The third one, you can use different technologies. So you want to use Elasticsearch for something, even though everything else was done in Postgres, no problem. You want to use a graph database because it's made a query that used to take 3 hours, take 5 minutes. Awesome, build a projection for that and you're off to the races. Better security, you can create event stores that are read and append only. So there's not even an option if your site were attacked for anyone to tamper with existing events that have been recorded. Your projections can be audited against the event stream. And you can create web applications that have read-only access to the projections. So the models that they're reading from, they can't even update. So, quick example. I am at almost 30 minutes now since starting, so I'm going to go through these a little bit quickly. We talked about Cucumber earlier. This is an example of a gherkin. So this is the scenario that we're going to try and examine in some detail. So we've got registering a new client and confirming an email address. They both have the same background. If you haven't seen one before, you can check it out after or on the slides. So this is the test running behind the gherkin. So when the step there that said when I click the register button, this is the code that runs that test. And this highlighted section in the middle is actually recording the command. So I'm calling a stream manager. The stream manager is something in my own library which knows what the information about a stream, what sort of aggregate it's dealing with. And when I want to record a command, I pass in the ID for it. Normally this would be a UUID. This is a callable. So I'm calling the register command out of the user commands instance. This could be any callable. And it's back to that function we looked at earlier that just takes a command and a payload and generates events. And these are the parameters for the register function. So it's the ID again, because it's now going to a different function. It's the registration form email that was filled in, and the password, and a token for the email confirmation. So our front end is going to generate a token randomly and just plug it in there. So that's going to feed back into this loop. We're not going to go back through the whole loop. And this is the register command. Now this is doing some things that are a little bit of a shortcut here, and I would like to talk really briefly about a better way to do that. So it looks to see if it's not null. If the library around it has looked at that ID and said, okay, great, yeah, I can load that aggregate for you, that means the ID was already taken. It can't be re-registered. So we're going to throw an exception. We're going to look and see from a projection, do we already have this email confirmed? If so, throw an exception for that. We're just checking our business rules here. And if it's already been requested, we're going to throw a different exception. Because if it's been requested, we want to do something else with the user. Oh, do we need to resend the email confirmation? What do we need to do? This is just another thing from the library, and it just lets me put pairs of parameters here to build up a list of events. So this is creating a registered provided email address and changed password event with their own payloads. Now the better way to do it. Here, it's tied really tightly to that projection, and that's not good. It makes for a nice, quick little demo here. I see a shaking head. He hates it. I don't blame you. So a better way to do this would be to have a separate aggregate root where we use email address as an identifier. And normally using email address as an identifier in CQRS is a huge no-no because people change their emails and it doesn't identify them. But in this case, we're using it to identify the email address. And we're really just using it as a way to say that we need that to be unique. And we can talk more about that after, but I am very short on time right now. So we've got 3 apply functions for these, recording the ID, setting the email information, storing an encrypted password. We've got a projection. So this goes back to your question about how projections are stored. So here, when it's on registered, it takes its, I'm just using DBO here, and on registered, it just creates an initialized record. There's nothing in it yet because it doesn't know the rest about it yet. But if we look at the other event handlers for projections, it fills in the requested email address when they request one, and it sets the encrypted password when that request comes through. Yeah, so it's one projection, but there's 3 methods that are hooking different events that all affect the same table. So if we go back to those, you'll see they all work on the user table, update user, insert into user. So these are all the same table, so they really are the same projection. Well, I would have to write something that generated the snapshots and have it just run on like a cron job or something every night. Okay, and this is the process manager. So this looks at when a user is provided an email address and creates a command or actually tries to record the command. So it passes it back in, which makes it recursive, passes it back into the stream to record the command and send the confirmation message. And the command will actually do that. So here's code for that command handler. It tries to do it. If it has a problem, it can throw an exception. Sorry, going fast here. When they follow the link, we record the confirmation command. And that command looks to make sure the token matches. And if it does, it generates an event that they have confirmed their email. And we just set a flag. And the projection sets the confirmed to match the requested for that ID. So sorry to whip through that source so quickly, but I hope it gives you a sense of these small little bits, each doing a small amount to build these things up. So moving forward, we can do some interesting what-if scenarios. We can do things like, say, copy an event stream and say, what would have happened if this happened a year ago, right? So we can make some interesting recalculations by reprojecting things based on what-if scenarios for what might have happened in the past. Offline events. So if you've got mobile devices that may not always be connected, they can queue up events and submit them to a common event stream later. You're going to have a little more work on that for concurrency and making sure that events don't cause business rules to be invalidated. Ephemeral event stores. This can be used for things, again, in the mobile world, gaming. If you've got a multiplayer game, you might have it actually build an event store on each device that's just based on a current play or a current turn. And you don't care. You're not going to store it. But the application can use it as a way to manage state and share state between multiple players. And I think we're going to see more people using CQRS in a non-distributed way. And when I say that, I mean things like commands that can say no and getting rid of message buses and things like that when they're not always strictly needed. I think that's going to make it easier for people to adopt. Here's a few resources. Domain-driven design quickly from InfoQ is like a distilled way to get your head around DDD as quickly as possible. There's a couple of really good DDD sort of canon books, the red book and the blue book. If you can't get through those, you have my deepest sympathy. I don't blame you at all. That's the Coles Notes version right there. HealthForce makes some incredibly good books if you've read any of their stuff, really approachable. They're writing a DDD book right now. If you go to this site, you can get on the beta list. They've got the first 2 chapters and half of the 3rd chapter already written. So you can get early access to that. Some really great introductory material. And the CQRS journey from Microsoft is documentation from about 2012 to 2014 when their Azure team was working through all this stuff. And this is where they've documented all their successes and failures. So it's a really good learning resource. So I hope this has helped. I hope I haven't added to the mysticism around it. I hope this makes it a little bit more approachable. I hope you've got some idea what all this alphabet soup really means and how it can be useful to you. And I am open for questions. No? Yes? Well, my experience is very limited. I'm only just now at the point where I work where they're starting to let me do this kind of thing for production. Nothing I've worked on has actually gone into production yet. So my knowledge is very theoretical and I know nothing. But my feeling for this is that if you've got something that is really naturally a CRUD application, like an address book, and you don't care to lose the information of what was, for example, when you ship something, do you care that you shipped it to the address that was in the database the day you shipped it, or the address that's been updated today and is no longer the address that you shipped the item to, right? So in those cases, no, you don't want to use CRUD. But in really simple cases where you don't have those issues, if it's just forms and you're hitting update and you want all the fields to get updated and that's really all you need and you don't care about losing the data, CRUD is great. If it's just too much, like there's a lot of complexity here. And I think with CQRS and ES, you've got a spend for upfront complexity that pays you back on the tail end. You know how when your application is 90% done, you're halfway there? I think that kind of complexity and that problem is more common in the world of CRUD because with CQRS, you've got things broken out in a way where you don't run into as many walls at the end because you've left yourself a lot more doors open to create those read models in ways that are more useful or to reinterpret old events in a more useful way. Or if you haven't launched your application yet, you've got an easy way to build new stuff in. So I think for things with a lot of complex business logic, like BPMN and that kind of stuff, when you get into those fancy diagrams and this happens and it triggers that, and you're already dealing with something highly evented, CQRS is a really natural fit and is going to make your life a lot easier. Yeah. Yeah, if you've got complicated workflows, you're dealing with domain events already, and CQRS is a really natural fit for that. Yes, sir. Yeah, I like to avoid eventual consistency as much as possible. So basically, in the case of a web application, if there's an HTTP endpoint, whether it's a full page load or a REST API or anything, I want all that sorting out of events and commands and all the stuff that has to happen in order to give the user a good experience to happen right inside that request. And that's something that traditionally the CQRS crowd has not done because they've always architected things around big distributed systems. And I think that really comes out of the way the Azure people were thinking because that's the services they were selling. But I think for most people, you can process all that stuff just right then and there, and you don't have to worry about eventual consistency. By the time your HTTP service responds, you've already got that worked out, and so there is no eventual consistency problem. If there is, then you've got a UX problem. Yes, sir. Great question. There's eventstore.org. I probably should have put it on the resources page. But it's a big open source app. You can download a Docker container to run it in either prod or in dev to start playing with it. But it's a database that's built from the ground up just to be optimized as an event store. For most applications, anything is going to work okay. I mean, it's such a simple thing, the event store, that MySQL, Postgres, Microsoft SQL Server, or it doesn't have to be relational, right? Use Mongo, use Elasticsearch. It's really, really wide open. So there are some really good databases which are designed specifically for the right model, but you don't need them. Like, they're nice. They have some nice features really built around CQRS, like the versioning and all that kind of stuff baked right in, but it's not required. Yes? Yeah, so there's a couple of approaches to that. And I think I would look to the people working in REST. So the question was, what happens when your events become backwards compatible with the older events? So we've had a change to our business requirements. We've got different payload data coming into an event. And now this event has different data in it from our old events, but we need to replay both. So if you look at REST, the people developing REST APIs have to deal with the same thing because they've got clients that are going to be calling it, and they may be calling an older version, right? Even when I just update my web application and somebody's cached some JavaScript, which is expecting an older version of the API. So those people have already thought through that problem in a lot of detail. And the bottom line is you can sort of duck type your events. So you can say, if I've got this in the payload, awesome, use it. If I don't have it in the payload, then it's an older version, and we're just going to deal with it based on our business logic of the day. The other thing you can do is actually version your events. So instead of having an event handler for the user-registered event, you're going to have an event handler for user-registered 1 event, user-registered 2 event. They're both user-registered, but one is version 1 and one is version 2. And they've got different expectations about what's going to be in the payload. Yes, sir? The hope is that your projection is completely flat, so you don't have anything other than just what's in it. If you really need to have, if I've got 2 aggregate roots, and they both have different projections, and those 2 projections need to be related, then I would say I did it wrong, because I would actually have a projection on this aggregate root and a projection on this aggregate root, both running their projection into the same read model. And that way it's always going to be up to date, and there's not going to be any dependency issues. Does that answer your question? Okay, yeah, we'll talk after. Oh. So debugging in a CQRS application, I find it's like the idea that it's really good with tests like the gherkins. And I know this doesn't sound like it relates, but I think it will. The idea is that for me, it makes debugging easier. Because for me, one of the biggest challenges in debugging is replicating, well, what did the user do to cause this bug? It's repeating the bug. With CQRS, I have a log of what the user did. I can copy that event stream into a development environment, put breakpoints in the projections that are generating unexpected read models, and go back and see, what? And it becomes a lot easier. I think, are we good? I mean, I'm happy to, any more questions, but just after, because it's been a long time. Thank you very much.